I'm Anil Kumar. Welcome to my series on fractions. In this video, we'll consider a model which is a number line model to divide fractions. There has been request from many parents who want to explain their children this model or dividing fractions using number line. So what I'm trying to say here is that we'll try to explain how you could divide one fraction by the other using this type of a number line. Let us say we have 3 over 4 and we need to divide it by half. How do we do using a number line? So that is the main concept. Now before getting here, we need to understand few other concepts. So I'll talk through what is division, and we'll have a quick overview of division, and then we'll consider these examples, different combinations where the number line model can be used to represent division. So when we divide, we may have to divide whole number by a whole number. We may divide a whole number by fraction, fraction divided by a whole number, or fraction divided by fraction. So these are the four cases which we will consider one by one. There is another model, let me name that also, which is called the area model. So if you are interested in area model, you can look into other videos. Now let's talk about division first, which is when we use the term division, what are we trying to say? So a common way is division is part of the whole. So that becomes our basic description for division at junior and middle level, right? So when we talk to our kids in junior classes, we'll say division is part of the whole. The key words for division which we are going to use are sharing and grouping. So these are the two key words which will be used in context of division. To give you an example, we can say 20 candies shared among 4 friends. It really means the key word sharing means division. 20 is divided by 4 and what you get is the result which is 5. Perfect. So that is how we relate division in examples. Another application could be grouping, as I said. So we could say 24 students grouped in teams with 6 each. Now, the keyword grouping indicates that we are talking about division. 24 students grouped in teams of 6 each will form 4 teams, right? So that is how we connect them. And now I hope you get some idea of how to explain our junior middle school students the concept of division, right? Now let's talk about some more things about it. Whenever we say division, these are four terms which we may use: divisor, quotient, dividend, and remainder. How are they related? So, as let's take an example here. Let's say we divide a number which is, let's say, 16. And if I divide 16 by 3, 3 times 5 is 15. And what we get is a remainder 1. So that cannot be divided evenly by 3. So important thing here is that if not a multiple or not divided evenly, then what we get is a remainder, as we get in this particular case. Now here, let me define all the related terms. So the number with which you are dividing is called the divisor. So 3 is the divisor. The number which is divided is called dividend. The answer is the quotient. Well, part of the answer is also the remainder. Now, it is important at this stage to understand that we can actually write 16 divided by 3 in the form of fractions, right? So that is how the fractions come into place. And we can say this is equal to 5 plus the remainder 1, which we have to still divide by 3. Do you see this part? So it is kind of important to understand how we write remainder. Remainder, which is still to be divided by 3, right? So that is one way to look into it. So in a way, this is part of remainder which is to be divided. Perfect. This is called the statement or the division statement. Okay, so let me write down this as division statement. Okay, so let's move on and see uh, other concepts of division. Division is multiplication by reciprocal, right? So this is commonly understood, but important concept once again. When we are dividing 6 by 3, it really means you are multiplying 6 by 1 over 3. 1 over 3 is reciprocal of 3, right? So division is multiplication by reciprocal. So you can replace the sign of division by multiplication. That is what we are trying to say. But in that case, the number gets replaced by its reciprocal. So if I say 4 divided by 1 over 3, we could write this as 4 multiplied by 3 and we get the result. So I hope you're getting this particular concept. So at many places, you may divide by multiplying by its reciprocal, right? Now here are some more important facts about division, which are kind of related to what we talked about. Division can result in bigger numbers. Now, this is sometimes a very difficult concept for students to understand. When you divide, the numbers may increase. Well, how? Can you give me an example? For example, if I divide 6 by half, we actually get 12. So it is a higher number. Do you see? So division by fraction, the result is a higher number. So that is very important to understand at this stage, that you can actually get an answer which is much bigger than the number itself. So whenever we are talking about division by proper fraction, we expect bigger number as a result, like you've seen here, right? So when you divide 6 by half, means it is same as writing 6 times 2, which is 12. Correct? So you can get a higher number when you divide by a fraction. Another thing which we saw is division may have a remainder. It is not necessary that when you divide always it evens out. You may be left with a remainder. Now we'll see how to treat the remainder. Now, related to the two things, here is an example. Pizza slices, when each is divided in 8 equal parts, so we get 8 times the number of pizza. The slices are 8 times. So that relates to the first example, which is division, since we are talking about dividing but resulting into more pieces. And the second one here is 16 candies shared among 3 friends. As we saw, when we divided 16 by 3, we got 5 in the quotient and the remainder was 1. Correct? Now, based on this, we had linked all these three things with a statement which says 16 divided by 3 is 5 remainder 1, which can be written as 5 plus 1 over 3 or 5 1 over 3. So you see how the remainder has been combined in the answer. So 5 is the quotient part, right? So this 5 is the quotient, and to this we add remainder, and 3 is a divisor. Perfect. This number 3 is the divisor. So the remaining part we have to divide by the divisor. What part of the divisor is left? So in short, this particular portion here, remainder divided by divisor, could always be thought about as what part of the divisor remains. When we divide, what part of the divisor remains? So in this particular case, 1/3 part of the divisor remains. 1 out of 3, correct? So the remaining remainder is 1 divided by the divisor, and it signifies that we have still to divide 1 amongst 3, right? So it really means, literally, we still need to divide one candy in 3 friends. So that is what remains, and that is what is called remainders. So I hope you're getting the concept of remainder. And in the answer, that is the influence. Perfect. Now, with this in mind, let's begin with our exercise of using number line to divide. So now the actual thing begins, and we'll take cases one by one. In the very first case, we are going to divide whole number by a whole number, right? So to keep it very simple, I have taken whole number divided by a whole number. And let's try to understand this process. We are trying to divide 6 by 3. So let's say this is the number line, right? So 6 divided by 3. So what we have here is, let's say 6, 1, 2, 3, 4, 5, 6. So that is the number 6 we have. We have 1, 2, 3, 4, 5, 6. We are going to divide this by 3. For the divisor, let me also show the divisor on a number line and similar divisions. Okay, so the same number line, the numerator, which is 6 for us, we're trying to do 6 divided by 3. So the number line in green is the 6, which is a dividend, and that is the divisor for us. So when we are dividing by 3, we have to basically group into 3's. So we have 6 divided by 3. That means this is first group of 3. And how many groups can we form? So we can make one group, and we can also make another group. 2 groups, correct? And therefore, we know that 6 divided by 3 is equal to 2. And that is the number line model. Perfect. That is how we could do it. Now the other example is 6 divided by 4. And in that case, we expect a remainder. So we'll see how to interpret remainder. So let's say this is the number line. And once again, we have the numbers 1, 2, 3, 4, 5, 6. So these are the 6 numbers starting with 0 always. 1, 2, 3, 4, 5, and 6. We are going to divide this by 4 this time, right? So by 4. So this is the divisor line which has the same size, basically 1, 2, 3, 4, 5, 6. But we are dividing 6 by 4. So the unit by which we are dividing basically is 4 this time. So this is dividing by 4. So when I divide by 4, as you can clearly see here, we definitely get one whole and we have a remainder. And we are saying that the remainder is this portion. This is the remainder for us. So this portion is remainder. So our answer is 1 plus remainder divided by the quotient. We are doing this time 6 divided by 4, correct? Let me draw a line in between, signifying that these are two different examples. The line should have been on the other side. Okay, so that is the line for us. 6 divided by 4. So what remains is these two portions. And how much are they for? Divisor is 4, correct? So what part of the divisor? 4. So you could write this as 2 out of 4 or even half, right? This is the same as 1.5 because 2 out of 4 is 1.5. So that is the result or the answer. So in this case, the answer here is 1.5, which you could also write this as 3 by 2 if the children are in grade 7 and 8. So we can convert this to improper fractions. Is that clear? So when you divide even by the whole numbers on a number line model, you can clearly see that out of the 6 numbers, 4 went through one time and 2 remain. And therefore, using the division statement, which we did last time, explain at this particular stage, so that was a critical part to explain, that 5 whole and 1/3, 1 out of 3, where 3 was the divisor. So here again, 4 is the divisor and what remains is these two. So we get our result 1.5. Is that point clear to you? So whatever we are doing with these whole numbers, the same concept will be applied when we use fractions, and therefore it is a good time to understand it. Perfect. Next example here is 4 divided by half and 4 divided by 2 over 3. Now this time we are dividing a whole number by a fraction, right? So whole number, which is a 4, is being divided by half. So let's again get to the number line concept. So here is the number line and the divisor for us we are representing in green. 4 is to be divided by half. So let's get to 4 divisions. So we have 1, 2, 3, 4. Correct? Always starting with 0. And in this case, again, we have 4 divisions, 1, 2, same number line, right? We are using the same scale. Now, we are dividing 4 by half. So each unit which we are trying to divide is half. What is half for us? Half is this much, correct? Half. So let's clearly write down what we are dividing. We are dividing by half, right? So I'm taking another small division so that we could represent half. Is that clear to you? Now let us see how many halves can be accommodated in 4. So we got 1/2. So let me show this as 1, 2, 3, 4, 5, 6, 7, and 1, 8. So in all, we have 8 halves evenly divided, right? So we can write down our answer, which is 4 divided by half is equal to 8. There is no remainder. Perfect. There is no remainder. Now let's do the next example, which is 4 divided by 2 over 3. So let's begin with our number line once again. Divide. Number line always have numbers on it, right? So we are going with a very flexible scale like this. Begin with 0. We are considering only positive numbers. 1, 2, 3, 4, and so on. But we'll consider only 4 numbers. We are using different colors only to make things simpler for us to understand. And here is the same number line, same divisions, right? Now, we are dividing 4. So the number which we are dividing is 4. So this is the number which we are dividing. And 2 over 3. Now, how do I get 2 over 3? Now, that's kind of tricky. So we need to divide into 1/3. So the scale which I have, let me divide it into 1/3. So each division I am dividing into 3 equal parts. We can also do this with common denominator, which I'll explain you later. So here 2 over 3 really means 2 out of 3. So that means this much portion. Is that clear to you? So 1 out of 3, this is 1 out of 3. That becomes 2 out of 3, the next division. So 2 out of 3 is the unit which is being shown here. This is 2 out of 3. Is that clear to you, right? So we'll see how many 2/3 go into 4. Perfect. Let me use this shade as we did earlier. So we have 1, 2 out of 3. Then we have the second one. Then 2 divisions of 1/3. That's what we're trying to see, right? So like this. This is what we're trying to figure out. Do you see that? So when you do this, you can now count your answer. So we have 1, 2, 3, 4, 5, 6. And so I can write 4 divided by 2 over 3 is equal to 6. It evenly divides. And this is the number line model which signifies the division process. Perfect. No remainder in both these cases. Next example is to divide a fraction by a whole number. Right? So this time we'll understand how to divide a fraction by a whole number. So we are dividing 3 by 4 by 2. Now this is very interesting. Let's try to understand this process. So again, let's have a number line, right? So we'll make a bigger number line this time. Okay. So let's say the number 1, 3 by 4 is, let's take this as number 1 and this as number 2. Well, okay. So in this case, starting with 0, this is our number 1 and that is number 2. We have to divide 3 by 4 by 2. So to get 3 by 4, which this time happens to be in the numerator, we'll divide this 1 into 3 equal parts. Rather, 3 by 4 it is. So we are going to divide this into 4 equal parts. Correct. So let's divide this into 4 equal parts. The 4 parts could be first half and then 2 small. So 4 equal parts. Perfect. So we get our number, which is 3 by 4. So 3 by 4 can be represented as 3 1/4. So that is 3 by 4 for us. Correct? So this number here is 3 by 4. Each is 1/4. So that is 1 by 4. This is 2 by 4. And that is 3 by 4 for us. We have to divide this 3 by 4 by a bigger number, which is 2. Correct? Now, in this particular case, when you divide 3 by 4 divide by 2, what we see here is it cannot be divided. So we get 0. So when we get 0, something remains. And what remains is this portion. 3 by 4 remains. Now we have to see how much part it is of the divisor, which is 2. Do you see that? So it is 3 by 4 remains, and we have to still divide this by 2, right? So this is that 2 comes in the denominator. So we could write this as 3 by 8. So 3 by 4 when divided by 2 gives you 3 by 8. So it goes in 0 times. As far as the remainder is concerned, we have to divide the remainder by the divisor 2. Correct? So 4 times 2 is 8. So we get 3 over 8 as our answer. Does make sense to you, right? 3/8 of the whole 2. So this portion here, which was remaining, is 3/8 of the whole. Correct? So that is how you could actually explain division with a whole number. Now let's take the next example, which is dividing by a fraction. A fraction by a fraction, right? So we have a fraction which is being divided by a fraction. So here is 3 by 4 and the divisor half. Since these numbers are less than 1, we'll take 1 as from 0. Let's say this is 1 for us. Okay. To get 3 by 4, we are going to divide this into 4 equal parts. So that is 1 by 4, this is 2 by 4, and that is 3 by 4. And half is also equal to 2 by 4. So we can think about common denominator. Now that brings us to the concept of equivalent fractions. So we are saying we have to divide 3 by 4 by half. Now I can convert half to 2 by 4. So if I multiply by same number in the numerator and denominator, the fractions are equivalent. So what we're trying to say here is that 1 by 2 and 2 by 4 are equivalent fractions. So these statements are actually same statements. Correct? So it helps you to understand better. So common denominator really helps. So in this particular case, 3 by 4 is being divided by 2 by 4. So the situation is that we have 3 by 4 and we are going to divide this by 2 by 4. Correct. So that is what is the situation. Now clearly when you do this division, what do you get? I'd like you to pause the video and write the answer at this stage. So when you divide 3 by 4 by, let me write 2 by 4 instead of half, we definitely get 1 plus this is the remainder r. Correct? How much is this remainder? What portion of this is the remainder? So if you compare these two portions, you get half. So that is how you get 1 plus half, and our answer will be, you could write this as 1.5, or you could also write this as 3 by 2. Does make sense? So once again, let's highlight this. What part of the divisor remains? So this part is half of the divisor, correct? So half of the divisor remains. Do you see that? So 1 plus half gives you 3 by 2 as your result. So that becomes your answer. Clear? So again, this question becomes very important to ask how to relate remainder with our solution. Perfect. So it goes one time fully, and what remains has to be divided by the portion which was the divisor. So you get half of it. So you can compare the sizes. Let's take two more examples to really understand this fraction divided by fraction. It's kind of tricky. Now, we have an example here which is 1 by 3 divided by half. Now we'll go with the concept of common denominator as it really helps. So first, let's make equivalent statement. We could write this as equal to 1 by 3 and 1 by 2. We can make both denominators as 6. So we could write this as 2 over 6 divided by 3 over 6. Since the LCM, the lowest common multiple, is 6 between 2 and 3. So that is the minimum denominator which could be common between 2 and 3. Perfect. So that is how we could interpret. Now, let us see with a number line concept how to perform this particular division. So both the numbers are less than 1. Let us take 1, 0 and 1. Okay, let's take a bigger one. Okay, so we are saying 2 by 6 is the divisor. So this is 2 by 6 for us. And we are dividing by 3 by 6 or half. This is the divisor, dividend. So when I say 2 by 6, I need to divide this into 6 equal parts first. So let's do this. So that is half, and then each half into 3 parts. Okay, so you could think about, let me just draw these lines to relate the two things. Okay, so that was the 0. So we have 2 out of 6 being divided by 3 out of 6. So 2 out of 6, each is 1/6. 2 out of 6, that is 2 out of 6, correct? So this is 2 out of 6. And we have to divide this by 3 out of 6. So this is 3 out of 6. Can you divide? No, the divisor is bigger. So when you do this, we get 0 plus what remains. The whole thing remains, right? So the whole thing remains 2 out of 6. Now you have to see what part of the divisor remains. Correct? What part of the divisor remains? So these are 2 parts and this is 3 parts. So when you do common denominator, it is easy. 1, 2. So that comes in the numerator, and this is 1, 2, 3. 2 by 3 remains, and that becomes our answer. Do you see the result? Perfect. So you could write that 1 over 3 divided by half is 2 over 3. Once again, the question here what part of the divisor remains is key to understand. So the ratio, do you see that? What remains is these two parts, and here we have three parts. So 2 out of 3 remains, and that is the answer. So when you take common denominator, in that case, it really helps. Perfect. Last example is for you to do, which is 3 by 4 is being divided by 1 over 3. So first step, of course, will be to work with a common denominator, as it helps to compare the parts, right? Now, represent 3 by 4 on a number line. Also represent 1 by 3 on a number line. Use same scale. So when I say same scale, let's say both, this is 1 for us, right? So let us say this is 1 for us. So we begin with 0, and that is the 1 for us. Now, we should write an equivalent fraction for the division with common denominator. So it could be 12. You could also look into the concept of cross multiply to get common denominator. So which is, you could see like this. We are having 3 by 4 divided by 1 over 3. So to make it 12, we have to multiply both these by 3 by 3. 3 by 3 is 1. And here by 4 by 4. 4 by 4 is also 1. Multiplying by 1 does not change the equation at all. But it helps. We could write this as 9 out of 12 divided by 4 out of 12. Perfect. So, common denominator by cross multiplication, the key numbers 4, do you see this 4? And the other number, which is 3, comes here. So that helps us to get the answer. Equivalent fractions. Perfect. So this is another topic which you need to review, which is equivalent fractions. I will provide you link for equivalent fractions also. So now we are basically dividing 9 by 12. Let me rewrite the question. Is being divided by 4 by 12. So we have to divide this portion into 12 equal parts. So let's do it. So 12 equal parts means, first let's do half of it, and then we have to divide into, so this is 2 parts, and then we could do another half of it. So we have 4 parts, and now we can do 1/3, right? So 3 parts. Do you see that? So these are approximate drawings, but they really help to understand the concept. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 equal parts. So 9 out of 12 really means we have 6, 7, 8, 9. So it is up to this point. 9 out of 12. And the other number divisor is 1 out of 3 or 4 out of 12 is that much, correct? So let us see how many 4 out of 12 can be accommodated in 9 out of 12. Of course, one of them is right there, and then 1, 2, 3, 4, then we have another 4, 1 remains, correct? Now this is how much of the remaining, this is what you have to look into. Perfect. So we have 2 parts as a whole. So I could write this as 2 wholes plus the remainder. The remainder is this much. And this is 1 out of what remains. Let's rewrite. This is remainder. Compare it with the divisor which is right there. So this much is 1/4 of the divisor. So 1/4 remains. So the portion which remains is 1/4 of the divisor. So we get 2 plus 1 over 4 as the answer. Correct? And therefore, we could write this as 2 1 over 4. And here, the answer will be 2 1 over 4, which is same as 9 out of 4. Correct? As an improper fraction. So, I hope you have learned the technique of dividing using number line. Key concept, once again to remind you, is when it goes evenly, that is not a problem. But the problem is how to incorporate the portion which remains. Whenever something remains, we have to see what part of the divisor remains. So it is 1 out of 4. That was our divisor, right? 1/4 remain. So that is the key to us, and that brings us to the conclusion. And the answer is 2 1 over 4. Another important is a check. So you can see that when you have the same denominator, the check is the numerator's ratio. 9 and 4 is your answer, right? 9 out of 4. So that could be a good check for you. Perfect. So I hope that really helps. That is how we could use the model of a number line to divide. So we began with the concepts of division. I hope that is clear. Division is all about sharing and grouping. These are the examples which you could always give to our students. And then that is a division structure. The terms which are commonly used are divisor, dividend, quotient, and remainder. It is kind of important to understand how we're treating the remainder. Remainder is still to be divided by the divisor. And so we get this number, 1 out of 3. And this relation, if you have understood, in that case, all the divisions which we have done so far, taking care of remainder, 1 out of 2. Do you see that? So 1 out of 2, that was our remainder out of 2. So we got this 1 out of 2 as our answer. So we are looking into what remains, how much portion of the divisor remains, which is to be added to the quotient which goes fully into it. And that is the key question which helps us to get the right answer and also represent the situation on a number line. So representing is easy, but concluding the answer is kind of tricky since we need to associate the remainder with our answer. I hope that makes sense. Feel free to write a comment, share your views, and if you like and subscribe to my videos, it'll be great. Thanks for your time and all the best.